So Algebra 1, Unit 1, Ratios and Proportions in the Criminal Justice System. What I want you to do first is to go read this link if you haven't done so yet. It will give you the basis for what we're talking about today and let you know where the information comes from. Like most things, it is not unbiased, but it is very factual. It uses very specific numbers and data to say what it wants to say. There are always going to be some circumstances in which you can make numbers say something that you want them to instead of what they're trying to. I don't feel like they're doing that beyond the story that they clearly want to tell. But I think the story they want to tell is a pretty true story. So if we go down here, in 2010, what was the US population? As I've said, this isn't in the sources, so we're just going to go look it up. And we just do that by going into Google and we say 2010 US population. And so this right here says that in 2010, the population of the US was 309.3 million. And that's based on the census. So we can be pretty confident in those numbers. So we'll go back over to our work. So we have, in 2010, we had 309.3 million people. In the US in 2010. Now, I'm not going to write full sentences for all of these because I'm speaking them out loud. I do encourage you to go ahead and write full sentences for your answers, because what that does is it gives you a chance to think about whether or not your answers make sense. I don't care about the grammar or the spelling or anything like that. I simply want you to make sure that you're answering the question that was asked. And the easiest way to do that is to answer it as a sentence. Now, if writing really isn't your thing, you can answer it as a sentence even in your head. I just need you to make sure you are interacting with the questions and not just giving the easiest answer. So next page. If 0.9% of the population was native, this means that 0.9 of every 100 people is native. That is what a unit ratio for population generally is. There's a little bit more to that, and we'll talk about it in a second. But first, I want to go over what the standard definition of a unit ratio is. What I basically expect you to say for this one is either it's a ratio, a two-term ratio with a second term. A second term of 1. Basically, what this means, and when you Googled this or searched it on the internet to find out what it means, and this definition didn't make any sense, I expected you to go do a little bit of research. So it's a two-term ratio with a second term of 1, and basically this is things like miles per hour. We want to normalize them. We want to have them be comparable. If my daughter says it took her 15 minutes to walk 1 mile, and my son says it took him 30 minutes to walk 2.5 miles, a unit ratio allows us to compare those two numbers in a sensical sort of way. If I say it took me a half an hour to drive the 20 miles someplace, you're probably automatically converting that in your head to 40 miles per hour. Another example of a unit ratio is runners tend to talk about minutes per mile. So they talk about things like I run a 10-minute mile or I run an 8-minute mile. And that's another example of a unit ratio that's a little bit, it's kind of flipped on the one above it, but it's what makes sense for running and walking. Now, this does not make sense for population. If I say 0.9 of every 100 and I turn that into a unit ratio, then what I'm actually saying is 0.009 per 100. And that one doesn't make any, oh, sorry, not per 100. Per one person. And the problem with this is it just doesn't make any sense. I don't have a good idea of what that means as far as a larger population goes. If I say 0.9 out of 100, then I can say to myself, oh, about 1 out of every 100 people is native. It's not so much easier to say, oh, what 0.009 out of 1 people is native. That doesn't make as much sense. And our unit ratio isn't always going to be per 100 people. Sometimes for coronavirus, we talk about cases per 100,000. Because talking about cases per 100 doesn't make sense. It makes sense more on a 100,000 scale. So unit ratios for people can vary, and they can vary for other things too. Like when you talk about how much is grown per acre or per 100 acre or things like that with crops. So just keep in mind that a basic idea of a unit ratio is to normalize and give us the ability to talk about something in a meaningful way. So now we're on to how many Native Americans were counted in the 2010 census. I could do this as a percent and just use my percent knowledge, but I don't want to assume that you have that knowledge because not all of us have understood all of the math classes we've had or gotten all of the math classes you have. So I'm going to show you how to solve this a consistent way for proportions. And you can do it the way that makes sense for you as long as you understand it and get the right answer. So 0.9 out of 100 US citizens are Native American. I want to find the equivalent proportion that is how many out of 309.3. Let me just make sure I'm remembering that right. Yep. Million. And I'm just going to put the million in parentheses because proportions don't have units. So as long as I remember that this is millions, I'm good. So what I want to look at is see how I got from 100 to 309.3. I'm kind of able to look at that and see that on my own and see that 100 is a nice round number. So I multiplied it by 3.093. To get to 309.3. If you don't understand how I came up with that 3.093, just by looking at it, don't worry. There will be some harder ones later on that I will use to show you how to come up with this number. So I'm going to do the same thing, and you can plug this into your calculator and make sure that 100 times 3.093 gives you 309.3. That's a useful way of double checking your work no matter what. So I'm going to do the same thing to 0.9. I want to multiply it by 3.093 so that I have an equivalent proportion here. And so 0.9 times 3.093 is going to be 2.7837. And I could be tempted right here to leave this as my answer. But remember how I talked about writing sentences? This is why we want to do it. Because I would sit here and I would say 2.7837 Native Americans were counted in the 2010 census. That doesn't make any sense. And then I remember, oh wait, million. So 2.7837 million Native Americans were counted in the 2010 census. Now, again, on this show, I'm not going to write that all out. I have that in the answer sheet written in a nice, neat sentence, but I'm not going to waste our time here. So next question. In 2010, how many people did the correctional system hold? And I asked you to go look at the link that I provided you. And the answer to that is 2.3 million people. And how many Native Americans does that represent? Well, we would be tempted to use our 0.9 information, but that would not be accurate because we're not looking for how many people in the US population there were for percentage-wise. We're actually looking for the 1% of Native Americans that are in the correctional system. So we want to say, and we got that, by the way, sorry, let's go back here. So we used this 0.9% for how many Native Americans are in the US population, but we're not looking at the US population anymore. We're looking at the correctional system population, where we actually have 1% of Native Americans are in the correctional system. So let's go back over here and we're going to do 1% of 2.3 million. And again, you can do that just knowing what percents are and that 1% means 1 out of every 100. Or we can come down here and we can do 1 to 100 and compare that to what? To 2.3 million. Now, I'm going to actually do this the other way and say a different way than last time because this is how I do things. I look at what makes sense in the situation. 1 to 100. 1 is just 1/100th of 100. We just divide. We divide 100 divided by 100 equals 1. And a different way of doing equivalent fractions or equivalent proportions is to keep this ratio the same. So if I take 2.3 million and divide it by 100, I get, we move the decimal point over, so I have to do this. Even though I'm a math teacher, I move the decimal point over twice, and I get 0.023 million. So I'm going to write that up here, 0.023 to 2.3. And our ratio in the fraction remains the same. So instead of, again, multiplying by finding out what we multiply or divide 100 by to get to 2.3. It just makes sense to have the comparison be in this direction. So that tells us we have 0.023 million Native Americans in the system. So let's write that out real quick. I'm going to erase this work here so I have room to write. So 0.023 million Native Americans. Now, that doesn't make a ton of sense. We will end up working with numbers like this as we go on so that we can keep our units making sense. But in my little head, I don't really understand what 0.023 million means. So instead, I'm going to write this as 1,000. And remember, thousands, in order to change from millions to thousands, we're multiplying by 1,000 because of the way decimals work, or the way place value works. Okay, so in order to get from 1 million to 1,000, we're changing it by 3 zeros. So I can move my decimal place over 1, 2, 3 places and talk about 23,000 Native Americans in the correctional system. So we've been giving a lot more detail to our prison populations for Native Americans than really makes sense. What we said was that there were 2.7837 million Native Americans in the census. But all we know is that Native Americans make up about 0.9% of the population. I'm going to do a quick demo on how significant figures look so that we can discuss why we need to change this information. So a quick lesson in significant figures. Significant figures are used in science a lot more than they're used in math, because in math, when we talk about numbers, we usually mean exact numbers. We're not estimating or rounding. Whereas in science, it's not always possible to use exact measures. You can't measure as precisely as you want to. You can only measure out to a certain amount of precision based on how accurate or how precise, your tools are. Basically, the idea is that if I say I walked about a mile to the school and it took me 13 minutes, I'm not going to divide out my 1 mile by my 13 minutes and come up with an exact how many miles per hour it took me to go. I'm going to say I walked about 4 miles per hour, because to say that I walked something like 4.21 miles per hour grossly overestimates what I intend when I say that I walked about a mile. And that's where sig figs become really important. So there's a couple of rules with significant figures. The first one is that you start from the first non-zero digit. So I can have my significant digit figures be something like 0.00156, and I'm going to start counting this at my first non-zero digit, that 1 right there. The second is that I'm not going to count trailing zeros as in 1,000. So let's get us a different number and we'll come back and calculate sig figs on all of these as it goes. So if I have 12,000, these 3 digits are just placeholders. They aren't giving me accuracy. Now, if I have something like 12,001, then I know that I know it accurate all the way out to this last digit. But if I have 12,000, I need these 3 zeros as placeholders. And so it doesn't make sense to we can't believe that they are accurate that far out. Scientists cover this with scientific notation so that perhaps you do know that it's exactly 12,000. Perhaps you had 12,001 and you gave one away. Science can cover that by doing things like saying it's 1.2 times 10 to the 4th. Oh, sorry. Or it's 1.2000 times 10 to the 4th. And that's something that's possible with scientific notation. But because this isn't a science class, we're not going to get into scientific notation. And that may mean that sometimes we have to fudge a little with our significant number digits and remember something like 12,000 actually has 5 because I took one away. Now, back to what we were talking about. I'm going to erase all of that and say that I start or I ignore my trailing zeros. Now, I'm going to skip over this adding and subtracting right now because I don't care. It's not going to come up. And no, I'm not going to skip over that. I'll cut that bit out. Okay, now that means that 0.00156 has 3 sig figs. And 12,000 has 2 sig figs. It also means that 12,001 actually has 5 sig figs. Okay. Couple more practice ones, and then we'll talk about the rules for adding and multiplying significant figures. 0.1590. This one has, we start at the first non-zero number. So we start here and we count 1, 5, 9, and we actually count this 0 too because it's a 0 after the decimal point, which is telling you that I do know how accurate that is. That is not a placeholder 0. That is an actual, I know how accurate my information is 0. So this one has 4 sig figs. Now back up to the rules about sig figs. When I am adding, oh, I can't erase all that stuff. Okay, I'll just undo everything. Just trash everything. There we go. I'm recording. Timothy wants chicken nuggets. Okay, so when we're adding and subtracting significant figures, then we care about the largest significant place value. So what that means is that if I were to add 400 and 39.2, since I don't know if this is 400 or if it's 425 or if it's 375, because I only know it's about 400, I care only about keeping everything on this side of the hundreds digit. So if 39.2 were, for instance, 64, if I were adding 400 plus 64, then I would go ahead and round, and this would be equivalent to 400 plus 100, and I would call this 500. But since I'm adding 439.2, this is 400 plus 0, which is 400. And again, this makes sense because I care about the place value, because if I say I have about 1,000 candies and you give me a piece of candy, it doesn't make a lot of sense for me to say, oh, now I have 1,001 candies. No, it makes sense to say, yeah, I still have about 1,000 candies. Whereas if you give me 500 candies or 800 candies, then I could say I have about 2,000 candies. And so that makes sense, okay? The rules make sense. Now let's get rid of all of this and talk about the multiplication rules, which are what we're going to spend most of our time on, but these addition rules will come up as well. So when multiplying or dividing, I count the sig figs in each number, and then I round my result to the smallest number of sig figs. So to use the example here, if I want to do 2.356 times 39, my computer or my calculator is going to tell me that that is 2.356 times 39. $91.884. 91.884. Now, this is really precise, considering that right here, I'm only saying about 39. And that's saying that I'm going to count 2.356 about 39 times, because remember, multiplication is just repeated addition. So about 39 times means maybe I'll only count it 38, maybe I'll count it 40, but about 39. So this is way too precise. And what we do to combat that, and I'm not going to go into the details of why so much, is we look at how many sig figs each of our multipliers has, and then from there we round our answer. So 2.356, again, we start at the first non-zero digit and we count. So this is 1, 2, 3, 4 sig figs. And 39 has 1, 2 sig figs. So 91.884, we want to only have 2 sig figs, but we do want to round. So we're going to count out from the front of the equation, 1, 2 sig figs, and then we're going to look at this third digit so that we can round. And if you'll recall from your rounding, if this digit is 5 or above, we round up. So our answer is going to be 92. And that just feels a lot better. Now, there again are reasons for this. Having to do with repeated addition and what makes sense. I don't want to go into those. They're not quite as obvious as the addition ones. But you want your sig figs to be equivalent to, when multiplying or dividing, you want your sig figs of your answer to be the same number of sig figs as the smallest of your multipliers. Okay? And that's all for sig figs. So, as you see, we needed to do some fixing of our numbers. I didn't want to address it when we first went over it because we were looking at the math part of it. Now we need to go back and look at accuracy. So 2.7837 million has 5 sig figs. 0.9% has 1 sig fig. And remember, it has 1 because we don't count this leading 0 because it comes before the decimal point and is just a placeholder. So we need to make it so that 2.7837 is actually only 1 sig fig, and we do that through rounding. So we are going to look at the 2 is the one we want to keep. The 7 is the one we want to round from. And we're going to go up when we round. So our answer is going to be about 3 million people in the United States are Native American. And that makes a lot more sense than this level of accuracy up here. Okay? And so we want to do the same thing with Native Americans in the correctional system. We said that there were 23,000 Native Americans in the correctional system, but we also said that they comprised 1% of 2.3 million. Okay, so 1% here, that only has 1 sig fig. 2.3 million has 2 sig figs. The smallest of these is the 1 sig fig right here. So we want our answer to have 1 significant figure. In this case, that's going to be the 2 that leads us. We're going to look at the 3 to see which way we should round. We're going to round down. So we end up with 20,000 Native Americans in the correctional system. And that's a lot more accurate or a lot more correct in its precision. It gives some room for error on either side. Because the information about Native Americans we have available is so imprecise, and they're fairly proportionally represented in the PRISM system, we'll not be discussing them in the rest of this question set. Now, I want to address something here. One of my students wants me to point out that a likelihood of why they are proportionally represented in the justice system isn't that they are more fairly policed in and more fairly dealt with in the American criminal justice systems. It's because a lot of Native Americans live on reservations with Native American police and their own force and their own judicial systems. So it's a much more peer-led process. Now, that doesn't discount the fact that there is bias even within minority systems that tend to favor white people, and that there's internal bias in everyone. But it is to say that it's going to be a lot more equitable because of that. So that's just something to keep in mind. So now we're going to go through and do this whole process with white people in the census, white people in the correctional system, all of these little details. So for my own knowledge, because I keep forgetting it, I'm going to put 309.3 and 2.3 up here in the corner. That's 309.3 million people in the census and 2.3 million people in the correctional systems. And we're going to move forward with this. So we're going to go back to our first page and look at our chart and see that white people account for 64% of the US population and 39% of the criminal justice system. So we'll head back here and say 64% and 39%. So white people are 64% of the US population. I'm going to do this particular one as a percent. You'll see that I kind of run through things in different sort of mathematical ways of doing things so that you can pick the ones that work best for you in each situation. So I'm going to say 64% literally means per 100. So 64 per 100 of people, so times 309.3. And don't forget that that is 309.3 million people. So what we get here is 197.952. So I will remind you that our 64% has 2 sig figs. 309.3 has 4 sig figs. So the 2 is what we care about here. So we care about the 1, 9. We're going to round the 7 up, and that's going to give us 200 million white people in the census. Now, there's a problem with this because our 200 has 2 sig figs. We know it does, but it looks like it only has 1 sig fig because we don't count trailing zeros. In this situation, if we go back and we look at our initial chart, every single one of the percentage statistics we are going to use has 2 significant figures. So we can remember that our final answers in this all have 2 significant figures and work with it from that standpoint. This is a problem with the fact that we're not using scientific notation. But that's a whole different ballgame and will make things, it will obscure the math more than I am comfortable with. So I'm happy to teach significant figures, less happy to teach scientific notation in this situation. Okay, we're going to do the same thing with our 39%. Remember that 39 percent means literally 39 per 100 times 2.3 million. And that's going to give us 0.897 million people. Again, we're going to look at our sig figs. We want to round this to two significant figures. 8 and 9 are going to be our two significant figures. We're going to look at our 7 and round up. And we're going to have 0.90. And we write this 0 because that's what tells us it's accurate to two significant figures. Our trailing 0 after the decimal point is not a placeholder. It's an indicator of precision. So we have 0.90 million white people in the criminal justice system. I'm going to tell you to keep this as 0.9 million because we're using million as one of our units. This is equivalent, of course, to 900,000, but we're going to keep it as millions. And we're going to do Black people in the census. There are, as we saw on the front page, 13% of the US population in 2010 was Black. So we want 13%, 13 per 100 of 309.3 million people. And that gives us 40.209 million people. Again, we want to get this to two significant figures. So that's our 40. We look at our 2 and we round down. So we have 40 million Black people in the United States. Again, our 40 is difficult. If it were acceptable, we'd put a decimal point back there to say it was accurate to two significant figures. Just remember it or give yourself a little hint on that one. Okay, now we want Black people in the correctional system. 40% of the population in the correctional system is Black. So 40% is 40 per 100 times 2.3. And what that gets us is 0.92 million people. And 0.92 already has two significant figures, so we are all set with that one. Latinx people in the census is 16% of the census. Again, I just got this information from the front page, the graph on the front. So 16%, 16 per 100 of 309.3 gets us 49.488 million people. And that we want, again, to have two significant figures. And we round this 4 down. So we get 49 million people in the US in 2010 were Latinx. Latinx people represent 19% of people in the correctional system. So that is 19 per 100 times 2.3 people in the correctional system. And that is 0.437 million people. Again, we want 2 significant digits. Put your box around the 2 that you're keeping. We don't keep this leading 0. Look at the 7. That rounds up. And so we have 0.44 million Latinx people in the correctional system. Okay, so now we're going to compare some things to each other using proportions in a number of different ways. I want you to learn to play with the numbers to see how they feel to you, so you get an actual understanding of what all this data means. That's really important when reading about things or looking at numbers, is that you work with them until you really understand what they're representing. So the first thing we're going to do is look at the proportion of people in the correctional system to the people in the census. So there are 2.3 million people in the correctional system, and there are 309.3 million people in the US in the year 2010. Now, we want to turn this into a unit ratio so that the numbers make sense. So unit ratio, remember, means we want our ratio to end in 100. There are a number of different ways we can do this. For instance, I can fairly quickly look at this and say, oh, if I divide by 3.093, then I'll get the answer that I'm looking for. I'll turn that into 100. But I encourage you to feel that and see what it looks like and see if you can kind of see how the numbers work. But I also want to give you some tools for making that work for you. So we're going to go back and we're going to look at this. The easiest way to convert between ratios consistently is to go through 1. So if I divide this by 309.3, then I'm going to get 1. So that's going to equal 1. And then if I multiply it by 100, that's going to equal 100, which is what we're looking for. So first we'll divide by 309.3, and then we'll multiply by 100. And for a proportion to remain proportional, what we do on one side, we need to do on the other. So we're going to divide this by 309.3, and then we're going to multiply by 100. So 2.3 divided by 309.3 times 100 is 0.7436, and some more numbers. I don't need to bother with the rest of those numbers because if you'll recall, we need to use our significant figures. Both of these have significant figures, or sorry, not both of them. 2.3 has 2 sig figs, and 309.3 has 4 significant figures. So we want to round our answer to 2 significant figures. We look at the number afterwards, we round down, so we can say that this is 0.74 to 100. Roughly speaking, this means for every 100 people, about 3/4 of them have gone through the correctional system in the past year. Now, this doesn't mean that they have stayed there. That doesn't mean that at this point in time, that many people are in the correctional system. It doesn't even mean that many distinct people have made their way through the correctional system. It simply means that many people, that many times has someone been put into the correctional system. So this could be someone getting picked up for a drunken disorderly 10, 15, 20 times throughout the year, or homelessness is another frequent offender. Spend a night in jail, get released. That person represents 10, 15, 20 times that someone has been put in the correctional system throughout the year, although they're only one person. So you need to keep that in mind when considering this number, because some of our numbers will look unrealistically big, and that is why. So now we're going to do this for white people, we're going to do this for Black people, and we're going to do this for Latinx people. So our proportion for white people is, undo that, is 0.90 million people in the correctional system and 200 million people in the US. Now, I'll remind you real quick that this 200, even though it looks like it only has one significant figure, actually has two significant figures. We just didn't represent it with scientific notation. We just had to remember that. Now, I did tell you that I'll usually tell you a good, solid, constant way of doing things to convert this to a unit ratio. But in this case, it's fairly easy to see that in order to get from 200 to 100, you simply divide both sides by 2. So if we take 0.90 and divide it by 2, we get 0.45, which has two significant figures. So we are all set with this question. Now, if we're going to compare the proportion of Black people in the correctional system to Black people in the census, we need to do 0. Oh, let me undo that. 0.92 million Black people in the correctional system versus 40 million people in the United States. Now, again, this one I see, let me get my 100 down here. To me, looking at this, because I've had practice, I can see fairly quickly that to get from 40 to 100, you simply multiply by 2.5. We're not going to do it that way. We are going to do it the same way we did before, where we say we divide by 40 to get to 1, and then we multiply by 100 to get back up to 100. Now, if you can see that you multiply both sides by 2.5, I encourage you to do that. There's nothing wrong with that. So we're going to do that to our other side. Divide both sides by 40, multiply both sides by 100. So 0.92 divided by 40 times 100 is equal to 2.3. And again, our 40 had 2 sig figs. We wanted to put that little decimal point on the end. We're just not displaying it scientifically, so we have to remember that, which means our final answer has 2 sig figs, which we do. Finally, Latinx people in the correctional system. We want to represent 0.44 million Latinx people in the correctional system compared to 49 million Latinx people in the United States. Now, I want you to look at this again. So 49 to 100, you're going to look at that and say, oh, that is pretty close to being times 2. Same with the 44. So our final answer should be pretty close to 0.88 to 100. It's not going to be exactly that because 49 times 2 is 98 and not 100. But it's always a good idea to be paying attention to your data to see if your answer makes sense. So we'll divide by 49. We'll multiply by 100. What we do to one side, we do to the other. So we get 0.897 ... I'm not rounding my 7 because I'm going to round it anyway. So I've got 0.897. If you recall, I want this to 2 sig figs. And I will do that by rounding this 7 up, and I'll get 0.90. So that's almost 1 out of every 100 Latinx people are in our, make it to our correctional system throughout the course of the year. So now we want to know which ethnic group has the largest proportion of its population in the correctional system. So we'll go back and we'll look at our numbers for this. Our white population was 0.45 per 100. Our black population was 0.90 per 100. No, sorry, that was our Latinx. Let me see. Sorry, that was our Latinx population. So let me erase this. Our black population was 2.3 per 100. So we can look at these numbers. This is the whole point of doing a unit ratio, a unit proportion, is that you can look at these and say for every 100 white people, about half of that one is in the correctional system or has gone through the correctional system throughout the year. It's much easier just to say in the correctional system. So think about what I'm saying as I'm saying it, about what I mean as I'm saying it. So for the Latinx population, out of every 100 Latinx people, about 1 is in the criminal justice system. And for Black people, more than 2 out of every 100 are in the correctional system. And that's the problem we're discussing. It's not as easy as just saying Black people are over-policed. People will mention poverty in this. And when you're looking at statistics like this, it's really important to know how to control for various factors. That means you can't just look at Black people because they disproportionately also live in communities that are poor and don't get the services that they need. And so therefore, you could see a lot more petty theft and things like that in the Black population because of that. That's more a result of their poverty than their Blackness. But if you're going to make that argument, first of all, you need to actually look for the controlled data. And the controlled data is out there, and it still says that Black people are disproportionately arrested. But then you need to dig deeper and say, why are Black people disproportionately poor? And how can we turn that around and make that better? So you do need to control for information. You can't just say that a Black person, that 2 Black people or 2 people in the same neighborhood, the Black person is almost 5 times more likely to get arrested than the white person, because there are contributing factors, but those contributing factors are also part of the problem and can't just be explained away as contributing factors. Okay, so which population has the least? I think we can see that. About half as many white people enter the correctional system as Latinx people. So that's also a problem. So we're going to look at this data a different way. same data, just a different representation. And we're going to use Black people and white people because those are our extremes. You could do this whole exercise again, comparing Latinx to white people and Latinx to Black people. But we're just going to do this with Black and white people as represented in the census. So in the United States, there are 40 million Black people, and there are 200 million white people. So that is 40 million Black people for every 200 million white people, and we're going to convert that to a unit ratio, which means we want it to end in 100. So again, this one's fairly simple. I just divide both sides by 2, and I get 20 Black people for every 100 white people. Again, our significant figures, 40 and 200 both had 2 significant figures. We just can't represent them well. So 20 has 2 significant figures. And you may be tempted, like I am, to say this is 1 for every 5, but we're going to keep it as 20 for 100 because that is our unit ratio, and that's what will make sense when we can continue to do comparisons so that we can compare things to each other equally. So now we want to look at Black people to white people represented in the correctional system. In the correctional system, there are 40 million Black people. Sorry, not true. Thought that seemed wrong. There are 0.92 million Black people, and there are 0.90 million white people. So we want to, again, turn this into a unit ratio. This one is not as obvious, so we're going to go back. We're going to divide it by 0.9 in order to get it down to 1. And then we're going to multiply by 100. Again, if you see an easy, immediate way to do this problem, you are more than welcome to do it. Please do. So we need to do the same thing on the other side. We need to divide by 0.9 and then multiply by 100. And we get 102.2 repeating. That little 2 on the top means that it just keeps going on and on and on. Again, we need to get this to 2 significant digits. So I look at the 1 and the 0 up front, look at the 2, and I say I'm going to round down, and I'm going to say 100 to 100. So for every 100 white people in the criminal justice system, there are 100 Black people. That means generally the white criminal justice population is the same as the Black criminal justice population. And we knew this. If we go all the way back to our chart at the beginning, we can compare 40% of the criminal justice system is Black, 39% of the criminal justice system is white. So they're fairly equally represented in the criminal justice system. The problem is that there are many more white people in the country than there are Black people. And so that doesn't really work out in a favorable way. the statistics are really bad. And that's again why we need to do all of these comparisons, because you could look at that and say, well, they're equally represented. There is just as many white people in the criminal justice system as there are black people. And that's true, but there are a lot more white people in the country than there are black people. So they're not proportionally represented in the criminal justice system. And so that's kind of what I've explained here. Do the answers in questions 10, 11 fit with what you saw in question 9? So we're saying that there are 20 black people for every 100 white people out in the world or out in the country, but there are 100 black people for every 100 white people in the criminal justice system. This does fairly clearly tell me that there are many more white people out in the world or out in the country, and there are many more or equal numbers of black people in the criminal justice system, which means they are extremely disproportionately represented in the criminal justice system. They show up in the criminal justice system at 5 times the rate that they show up in the country. And that's a problem. And that's very similar to the numbers that we saw in question 9, or that we answered, that we used for question 9.